Ladies and gentlemen, my name is Moloti Tebogo Nakampe. I am the CEO and co-founder of Africa Business Integration. We are an artificial intelligence startup based in Cape Town, and it is an honor and a privilege to share with you OpenGesture for XR. Over the past few years, we've been engaging in extensive research into the use of artificial intelligence and mixed reality, virtual reality, as well as augmented reality. And we have been building a powerful application called OpenGesture using computer vision and using Unity game engine and a variety of other tools from Intel Corporation, such as the Intel OpenVino, which has helped us to optimize the OpenGesture models that can be used to recognize hand gestures, to also recognize sign languages, not just sign languages for Americans, but also African sign languages that incorporate African languages such as Zulu and such as Swahili as well. Today, we're going to start with a brief introduction of OpenGesture, as well as take you through how we have built the models. Please note that we have open sourced all the models through GitHub for all of you wonderful developers to be able to access them from anywhere in the world. We will also take you through the integration of game engines such as Unity and Unreal, and even your own custom game engine that you would like to use. Furthermore, we would also like to share some of the new improvements and initiatives that we're currently working on. Before we get into the initiatives of what we're working on for 2023, let's start with a brief introduction. So, what is the abstract and what are we trying to solve with OpenGesture? With OpenGesture, the functional problem that we're tackling is the identification of hand gestures and skeletal inputs to enrich a game user's experience. Imagine using your hand gestures instead of game controls to play a nice video game without having to use controllers and having to buy batteries to charge up your controllers and so forth. So how do we do it? We started off with data collection. Now, for all of you wonderful developers all around the world, you notice that with virtual reality and mixed reality as well as augmented reality, in order to build a machine learning model for those devices, you would need to obtain images that are in three-dimensional, or that is depth images. And Intel Corporation has built a couple of devices that can help, and in particular we have used the Intel RealSense depth cameras, the D435, to train a machine learning model that can take 3D images, not just the normal RGB or the red, green and blue images that we would use for our normal machine learning objectives. So we've collected over 2,000 images using the Intel RealSense cameras. So the first step was to collect the data set, and as mentioned in the previous slide, we've collected more than 2,000 depth images. Now with these images, we then use these images to train a convolutional neural network, and by convolutional neural network we refer to a deep learning algorithm which can take in an input of a 3D image as importance, and then learnable weights assigned and biases assigned to that model to various aspects and objects in the image. And it is therefore able to differentiate one from the other. That is, with the machine learning model, these 2,000 images that we collected over 100 images that were just focused on hand gestures for using numerics as input, such as 1, 2, 3, 4 in American Sign Language as well as the African Sign Language. We furthermore took hand gestures such as the peace sign, also took gestures such as squeezing, maybe dragging, and so forth. Now, we then trained a machine learning model using this convolutional neural network. After we collected this, we trained this model, we therefore went forward to use the Intel OpenVino. Now the Intel OpenVino helps us to optimize our model in order for our model to be able to run on multiple devices. So once the model is trained, we convert the model and optimize it into an intermediate representation format The OpenVino Toolkit Model Optimizer was utilized since it is an advanced cross-platform command line tool. The model optimizer allows for rapid deployment of deep learning models for optimal execution on endpoint target devices such as your CPU, such as your GPU, as well as the VPU. And for those who do not know, VPU stands for Vision Processing Unit. And we think that these devices are some of the most important devices used within the mixed reality as well as augmented reality and virtual reality environments, because we need to be able to process these visual operations. So if you would like to also train your machine learning model, the first step you need to do is collect your data, transform that data into a data set that you can input into a convolutional neural network. We recommend using TensorFlow from Google, which is a very great machine learning framework that you can use to build convolutional neural networks. After you've trained that model, now in order for you to run your model on a CPU or on a GPU as well as a vision processing unit, we actually recommend that you use the Intel OpenVino. It is open source and free to use for all. So the first step in any machine learning operation, particularly for OpenGesture, the first step for us was to be able to track the different gestures. Not just to detect or recognize them, but we needed to be able to track them. And to do that, we used a tool called OpenCV, which helped us to build a pipeline for us to track the different gestures. Particularly, you will notice that with this sample video that we're currently showing, we're showing you that we are able to detect the index finger, we're able to detect the peace sign as well as track it. We're also able to detect the thumb, the fist, and the palm, and as well as track it. As you can see, my colleague Tabo there, when he does that sign, it shows the peace sign. It says O gesture, which is open, therefore peace to the world, as we believe. So that was the first step that we took in terms of building the OpenGesture solution. Please note, all of this is open source. We've open sourced it through GitHub. So furthermore, if you would like to replicate this solution, just go to our GitHub repo and you'll be able to download it and replicate this OpenGesture tracking solution. Now, what we have done is that we've integrated the OpenGesture tracking solution as well as the OpenGesture recognition solution, as well as a couple of other detection models in order to provide a full solution for OpenGesture to recognize any kind of gestures in the virtual reality environment. As we mentioned during the machine learning model or deep learning model slide, we mentioned that it is very important that you also train the hand gestures to be able to detect the African sign languages as well as the American sign languages, so that you can be able to facilitate a variety of gestures from different ethnic groups. So we started off using the gestures for recognizing digits, and as you can see within the video, our model is currently able, on the RGBD, it's currently able to detect American Sign Languages, particularly for numbers, very well. We will also show you a simple demonstration where we are able not just to detect American Sign Language, but we're going to detect Setswana, which is a South African language used both in South Africa as well as in Botswana. So 2 countries are covered with this gesture skill. For all those who perhaps are not able to speak to us in natural language, then they can use the sign languages in both Setswana as well as in Zulu as well as in Swahili. Furthermore, we will show you another example that our OpenGesture model is very robust. It can also detect Xhosa or Zulu languages from Africa, with more languages being added throughout the year. As you can see, Kubili means 2 in the Zulu language, and then 1, 5 means Kuhlanu in the Zulu language. So as you can see, imagine a virtual reality environment or a mixed reality environment where all cultures and where all ethnic groups are covered, and they can speak their languages freely and their gestures freely without having to worry that this technology was not developed for us Africans. This is the work that we are doing at Africa Business Integration. We're trying to accelerate scientific development and artificial intelligence development from an African context. All open source technologies. Although we do have some other technologies that are not open source, but we are very providing open source tools is very close to our hearts. Now you can take these machine learning models and easily integrate them into a Unity scene where you can add it using the Intel OpenVINO plugin. Once you have optimized your model using the OpenVINO model optimizer algorithm. Now we shall take you through a sample application where we built an X-Drive simulation where you can drive a game car using the palm of your hand without using any controllers, using the two solutions that we mentioned. We mentioned what? We mentioned OpenGesture tracking as well as OpenGesture recognition, which recognizes the gesture, and the other one is able to track it. So now imagine you are able to the camera is able to track that you have selected a particular object in the game, and it is also able to detect whether you want the car to move to the left or to the right, or you want to accelerate or you want to de-accelerate. So this is how we're going to take you through it, and watch my colleague there testing it out for you. So as you can see, the cursor has been currently moved. For now we're a little bit slow, so the hand gesture was a little bit slow at this particular time. As you can see, the grid boxes there at the back. There we go. Once the hand is detected, there we go, now it's detected, you'll therefore see the car or the game object starting to accelerate, and using the tracking functionality we will be able to move the game object from the left to the right. There we go. As the hand moves towards the left and the right, we are now therefore able to direct the car. So imagine what you could do in your own game. Imagine what you could do for your own mixed reality experiences. As you can see, this is not yet very stable. It is only for scientific development, and we hope that all of the developers around the world will use these technologies to advance game development and the mixed reality environment. Using the hand tracking side, as you can see, there's a yellow grid box that shows left and right as we're controlling the game object. There are a variety of solutions that you could think about. Maybe even for collaboration purposes, you would be able to collaborate with your colleagues using your hands rather than using a conventional keyboard that uses wires and so forth and so forth. As well as maybe perhaps using some game controllers that require you to maybe charge them, as well as maybe add batteries to them. So we believe that with this technology we are advancing scientific development for all, not just in the developed countries but also in Africa, where we were born and where we live. We believe that with these technologies all of us can go forward. Metaverse for all and not just for the rich majority. So now comes the question, where is OpenGesture going? It is our pleasure to announce that we are integrating Amazon Alexa into the OpenGesture solution. This is powered by the PC Skills from Intel, which was a project that was done by Intel as well as the software innovators to be able to integrate Alexa into PCs, as well as into virtual reality devices, as well as into augmented reality devices and so forth. So please welcome to the future of what we would like to do with Alexa, and integrating not just hand gestures but also gestures such as speech, where you could also operate with Alexa to open a particular
Gesture
device.
Sign app for Windows 10.
Launching Gesture Sign app for Windows 10.
Launching Launching American Sign Language app for Windows 10.
Launching American Sign Language app for Windows 10.
The project is not yet completely finished. We are still working on it, and I hope that you guys have enjoyed our session, and please feel free to go to our GitHub repo, OpenGesture, and you will find all of the data set, the 2000 images that we have collected, as well as also the sample applications that we have demonstrated today. Thank you, everybody. Let's build stronger together.